All right, welcome everybody to the Murray Amateur Radio Club. We're going to do our quick presentation here on AREDN network design. This is pretty short. I'm going to go through it pretty quick. This is based on information that you will find on the AREDN documentation website. So the things that you see here hopefully won't be new to you if you have been on the AREDN site and looked at their documentation. If you haven't done that, and we get through this and you're like, I have no idea what he's talking about or what he said, then go look at the documentation website and all this kind of information is on there. And then also feel free to ask questions, feel free to interject comments as needed. Um, if the comments are not needed, please keep them to yourself. But that means you, Dan. Okay, so AirDen network design. We're going to talk about network design. So there are some considerations that you need to keep in mind when you're talking about building out an AirDen network or really any network, right? The first one is this a permanent network or a temporary network? Now, we're going to mostly be talking about a permanent network setup, but there may be kind of a combination of the two actually happening because you may have permanent sites that form the backbone of the network and have temporary sites that are mobile and may move around, that may be spontaneous. Like um, the served agency says, my gosh, we've got people grouping up at the park, at Murray Park, and we need a node over there. Somebody head over there with a Go kit and get set up and run a node over there. That would be a temporary setup, right? Um, but the differences are your permanent ones are like your backbone, your infrastructure, any fixed installations. If you've got a setup at your QTH, that's going to be probably a permanent setup. Your temporary ones are more spontaneous, maybe a mobile setup, a Go kit, something like that, something you can drag out there and set up when you need to. Geography and terrain are important to consider when you're setting this up. Remember, these frequencies that we're talking about, we're gonna talk more about it in a sec, but these frequencies that we're talking about, they really like line of sight and they really like no obstacles between the endpoints of the signal. Okay. So you don't want to put a node in your basement and expect it to reach anybody else. That's probably not going to happen. Yeah.
And they are highly susceptible to multipath.
They are susceptible to multipath. We'll talk about that a little bit as we move on, but um, they are also susceptible to interference from other things that are on this same band. We are not primaries for these bands. In fact, I don't think anybody's really a primary for these bands except maybe what part 15 Wi-Fi. I mean, that's probably it, right? So that's something to consider when you're planning where you're going to put stuff. What can you see? What can they see? Can they get to you? Can you get to them? That kind of thing. Also want to consider expansion and growth. We may build out a simple network initially, and as we add things to it, we realize that, oh my gosh, initially we were fine all on the same frequency, but once we've added 20 nodes, there's too much contention for that frequency and our performance is tanking. We need to segment and do some different things. We're going to talk about those different things as we move further along. But those are things to consider. What does it look like now? What do we want it to look like in the future? How long do we think that's going to take? We should plan ahead. Don't plan for the simple solution, plan for the complicated solution. Okay. Then when the complicated situation happens, you're ready for it. And then you also want to consider your applications and what throughput they require. Remember that this is a high-speed data network that we're talking about. And so some of the services that are probably going to be running on this network are going to be happy on a high-speed network. That doesn't mean you can't run software or systems or protocols that don't need a high-speed network. It just means you need to consider, am I going to get the bandwidth that I need for the services that I want? So for example, video conferencing is going to use more bandwidth than VoIP, voice over IP, like telephone calls. And that's going to use more than shifting around complex data like video files or image files or things like that that you can do non-interactively. And that obviously uses more than simple data like email, text chat, that kind of stuff. So consider what services you're going to be running as you plan out your network and lay things out. You may find that you want to use a higher bandwidth on your backbone links and a lower bandwidth on your temporary links, just because those links are carrying less traffic. So we'll talk about that as we go. All right, so let's talk about some network topologies. We have the mesh network technology. The beautiful thing about the mesh is it's dynamic, it's self-healing. If a node goes away, the system will find ways to route around that missing node. The data will try to always take the best path. And I put best in air quotes because sometimes the best path doesn't exist. And so sometimes it has to use a non-ideal path. When we get into looking at what I've got on my travel node, I'll show you some paths that we can get through, and you'll see kind of what I'm talking about. Um, there's also a point-to-point network topology. That's where you basically have your nodes in a line. So think about if we wanted to do an RF connection from here to St. George. How would we do that? We would have individual nodes spaced along at various places, probably where repeaters are on top of mountains would be an ideal place to put them, with microwave links, pretty good directional antennas pointing at each other and using that as each one goes to the next one. Obviously, well, maybe not obviously. We'll talk about the channeling and stuff in a minute. But what happens in a situation like this if the node in the middle goes away? The nodes on either end can't talk to each other, right? The nodes on either end can't talk to each other. So I thought I said only keep relevant comments out and keep the non-relevant ones to yourself. The hub and spoke topology is fairly common. If you're used to Wi-Fi setups like in a building or something like that, they'll use a system like this where you have a single access point and then individual machines will connect to that access point. That access point has some other network that it uses to connect into whatever else is going on, the internet or wherever. In a situation like this, you may have several of these with a well-positioned hub and local nodes that are talking to those hubs, and those hubs are using some other kind of connection to talk to each other. A tree structure is nice because it allows partitioning of traffic. You could say, okay, I want all my video traffic to stay on these frequencies or these bands, and then I won't run any email or anything over that part of the network. And I'll only do that on these other ones, and then they won't interfere with each other. It has similar drawbacks to the hub and spoke. If a critical node goes away, all the nodes downstream of that are disconnected, right? So that's something to consider. This is a good concept for linking different networks together. So let's talk a little bit about network links. So in this diagram, let me see if I can turn on, do I have a pointer of some kind? Pointer. Ooh, look at that. I got like a little red dot. You see my little red dot? Yeah. Okay. So what you see on here, they've broken this down into like a backbone network up here. And these guys are using 5.8 gigahertz links to talk to each other. And then here you've got each one of these sites has their backbone connection nodes, which are using directional antennas, and they've got sector antenna nodes, which are kind of this hub and spoke technology, right? And so your portable unit out here can connect directly into one of these, but it's not going to talk to a neighboring system. You may set up a relay node like this one that talks into the main backbone and also provides a sector antenna for a local cell around it. So things around it can connect in. So these are some different topologies that you might see. You'll notice that these are on 5.8 gigahertz. This one's on 5.8, this one's on 2.4, and this one's on 2.4. So in this layout, what they've chosen to do is run their backbone links on 5 gigahertz and keep their local or their temporary links on the 2 gigahertz, 2.4 gigahertz network. What we've been talking about with Aries, everything we've been talking about has been on 5.8 gigahertz. And personally, I think that's okay, but it is something to think about as we grow the network and as we expand. Do we want to plan for having both 5.8 gigahertz sector antennas and 2.4 gigahertz sector antennas on some of our central sites? So we'll talk about that more as we go. Do you have a question, Dave? No? Okay. All right, so our network links, we've got backbone links, we've got those relay links, and we've got what they're calling endpoint links. And the difference is basically where they're positioned within that hierarchy, right? So the backbone links talk to each other. The relay links connect into the backbone and provide a path for endpoint links to connect in. Sometimes endpoint links could go directly to the backbone. It depends on where they're located. AREDN is also now supporting a thing what they call a supernode architecture. And you're running a supernode instance, Sam. So what we have in a situation like this is you have a local mesh, and that mesh is connected into a mesh of supernodes. So you can think of this as like in that tree structure. These guys are at the leaf end of the tree, but they're actually fully functioning mesh networks. They're not just a single node. And then these guys up here communicate with each other over potentially some other connection mechanism. The typical one is tunnels over the internet, but these could be point-to-point Wi-Fi links as well. They don't necessarily have to be running over the internet. And we'll talk more about that as we move on. But I have some ideas, and I'll share those as we get close to the end of the presentation. Okay. So
What was the dotted line? Is that intermittent, like when it connects?
this line here? No, it basically just shows that this node is also a member of this network here, but it's at a different level. It's not, this is the super node, right? For this guy, for this. And you could potentially have 2 super nodes in here that were part of this upper mesh. And they would use meshing protocols up here as well. So if one of these tunnels went down, they would route around that. So if I was here, for example, and I needed to access a service that was running over here, I would follow my local mesh to the super node, get up here, and then go across this link to this super node down here, and then go into the node that I'm trying to reach.
So all the
If-
super nodes have like a routing table?
The whole system uses this OSLR routing, and they're moving towards a new system called Babel, Babel, I don't know how they pronounce it, but are they saying it's Babel?
It's unfortunate, but it's bad.
It should be Babel, but the way it's spelled, but
So these supernodes are roughly analogous to the
They-
internet backbone.
they are just,
Pairs.
yeah, kind of like that, right? These are just mesh nodes, just like any other mesh node. It's just that they are living at this other level, right? They're a separate mesh network from these separate mesh networks. So if I'm sitting here and I say, oh, what services can I see? I'm only going to see the services that are here, but I will see my super node. So if I think, well, gee, I wonder if there's a service that I'm looking for that isn't on my local mesh, I can ask my super node and he knows everything that's running in the entire network, right? So he can give me back a list of services that are running out in all of these guys. And then I can find the service that I'm trying to reach. All of these things are in the same IP domain. They're all a net 10. They're all routable. So from any node, you can get to any other node in this larger network. If this connection were to go down, the supernode would automatically route around it and go this way to get back to that system, right?
So even though they're on the same 10 network, they can, supernet, each group can be like, instead of a /8, which is 10, a /24 on group group A, a /24, and group B, and /24, and group C.
The way they're implemented, they're all /8.
All slash.
They're all /8.
Okay.
And so
you
they,
have
one big network. But as far as you talk about like a collision domain, this guy here, he probably can't see this guy directly. Right? So as far as he's concerned, the only two neighbors he can see are these two guys. So anything that happens over here doesn't bother this
So
guy.
does he send like a MARC?
This is where the OSLR protocol comes in.
Yeah, are we gonna talk about it?
I wasn't going to talk about it, but I can talk about it. I can talk about it briefly. So basically what OSLR does is it's open shortest link. I can't remember what the R stands for. Sam, do you remember? Routing? Probably routing. The idea is it maintains a table of its neighbors and how expensive it is to get to those neighbors, right? And so within this local network here, this guy is going to know about all of these nodes. He's not going to know anything about these guys or these guys, right? He's going to know all about all of these guys. And so he knows if I need to get to one of these guys, I need to send it to one of my neighbors. And it knows that this is going to be like if it was trying to get to this guy, there's two paths, right? I could go here, here. Well, there's really several paths. I could go here to here. I could go here to here to here. I could go here to here to here, right? And so what it's going to do is it's going to pick the shortest one of those and send it that direction. This guy, once he gets it, he's going to do the same thing. He's going to say, oh, I've got to get this packet to node whatever. And I know that it's this way. So I'm going to send it down that link. But if this link is down for some reason, he may turn around and route it back this way and up this way. Or if both of these links are down, he may turn around and hand it right back to this guy and say, try again. And this guy will try sending it the other way and see if that gets through. Okay. This all is controlled by this OSLR routing protocol. Yeah, Steve.
So I think where some of the confusion comes from is OSLR.
It's a layer 3 routing
It
protocol.
It acts like it's layer 3, but it's actually a layer 2. So it's kind of a hybrid 2-3
Yeah.
spanning tree, basically.
It's essentially a spanning
It's
tree.
essentially a spanning tree, but it's expanded out to the wide area.
Yeah.
What does Radiant Coleman have to say?
I don't know, but she probably write poetry about it.
She's the author of Spanning Tree, I'm sure we'll do that.
Yes,
So
I was referring to outline.
I don't know if that solves your problem or not, but the new protocol, Babel, sorry, it does a similar thing where it thinks it knows the route, and so it chooses the best route that it can find. One of the advantages of Babel is it will automatically detect and not use a loop almost immediately, whereas OSLR may send the packet back and forth a few times before it figures out where it really needs to go. Babel will never do that. Okay. And so that's one of the reasons why they want to switch to Babel. It's more efficient. The drawback is OSLR actually knows about services and Babel does not. So they have to run a separate service discovery protocol on the network in order to be able to tell where things are. So when you're running Babel routing, you also are running this second service discovery package, and I can't remember the name of it, but when you're running just OSLR, that's all you need. You just need the OSLR. The issue, of course, becomes using Babel is probably more memory intensive than using OSLR. You're trading efficiency on the RF for efficiency in memory. Right now, if you were to try to deploy a current build on one of the HAP AC lights, that machine does not have enough memory to do everything that you might be asking of it. And this is a problem for people because those have kind of become cornerstone nodes for home networks, right? If you're running a local LAN hotspot and Babel routing and OSLR routing at the same time, that machine is going to run out of memory and it's going to start killing things and it's going to fail. You have to turn one of those services off to run effectively. They're now recommending that supernodes be these, what are they called? The one WRT or WRT, open WRT1 nodes. And those are significantly more beefy and powerful than the old HAPs. But if you're running an HAP AC2 or 3, you're probably okay. But 3, you're definitely okay. But on the old AC Lite, your best bet if you're going to run that with the latest build is to turn off the LAN hotspot, because there's this piece of software that runs on there called the WPA supplicant, and it's the guy that manages the uh, basically the encryption for the Wi-Fi on the LAN, and it consumes a lot of memory. And so if you turn that LAN hotspot off, it won't run that WPA supplicant. It will have enough memory to run both OSLR and the Babel. Yeah.
In my experience, I'm running a light in my RV trailer with just one tunnel. And I can leave both the LAN and the 5G on that with just one tunnel. I'm not having any memory issues.
Are you running the latest build though?
Yes, with the latest build on that.
And it hasn't died on you yet?
Like I said, with just a single tunnel,
It's doing okay.
doing okay.
Hmm.
The one in my house, I've got, I think, 7 or 8 active tunnels coming in on that, and that won't handle it.
Yeah, you got to turn off the mesh radio entirely, turn off the LAN radio.
I don't seem, it seems to be holding out okay with the 5G turned off. It's still the 2.4 as a local link.
Yeah,
It's holding up on
it's
this.
doing okay.
But like I said, I definitely had, it was crashing daily.
Yeah,
If I had that 5G on.
Yeah.
So like I said, I don't use that anyways. Everything's device to device in the house.
Yeah.
So shut that down.
so that's something that they are concerned about, but they really want this Babel protocol because of the efficiency on the RF side. And so they're willing to live with it. So since they're willing to live with it, we kind of have to live with it too. Unless we want to fork our own project, which I don't think any of us wants to do.
Is 325 the latest?
They just released a new one, right?
No, just the other day.
Yeah, it's 325.5.
And that's the one where the incorporate.
That's got Babel in it. Yeah.
The dual routing.
Yeah, it has both Babel and OSLR.
If it had one of the previous dailies that Babel came out just within a week of the latest.
Yeah.
The 3.25.
Yeah.
Say if you've got one that's on a daily.
Yeah, it's the 325.2 is the previous release build, and it did not have Babel.
Yeah, they did just announce
It-
it.
yeah.
3 or 4 days ago. Yeah.
So, yeah, so keep that in mind before you upgrade if you're on an AC Lite. You may find yourself in a world of hurt with the machine crashing continuously. I ended up having to actually reinstall the OS from scratch to get back to the previous version. I was not able to even get it to stay up long enough for me to turn off the services that I needed to turn off in order to have it actually function. So just be aware of that. Yeah.
I'm
And-
sure there's much of a difference between the square white AC lights and I picked up the TC version, the
Yeah.
TC light. I'm not sure if they're black, smaller case.
I don't
I'm
know.
not sure if there's hardware difference on that.
I don't know.
So those are the ones I'm running.
They might have more memory. I don't know. You'd have to take a look at that and see. Okay, so RF characteristics are something that we have to consider when we're doing this, right? So we have three bands that are supported. There used to be a fourth one, but thanks to successful government lobbying by cell phone carriers, that one went away. The 3 gigahertz band is no longer available in the US. So there's the 5.8 gigahertz, there's the 2.4 gigahertz, and there's the 900 megahertz. I don't know if anybody around here doing 900 megahertz. There are some advantages to the 900 megahertz. There are some disadvantages, right? The amount of data that you can push through it is probably less on the 900 megahertz, but 900 megahertz is more likely to penetrate walls and things like that more effectively. Yeah,
And it's real expensive.
and it's expensive. So the 3 gigahertz equipment that we used to be able to use was the people loved that because there was no public Wi-Fi running on that, and so there was hardly any interference with their stuff, and it was great for backbone links. But the FCC decided they needed to make some more money, so they sold the bandwidth to some cell carrier or something. Anyway, so advantage of the 5.8 gigahertz, it's got 54 channels to choose from, so there's a lot of room in there. The 2.4 gigahertz in the US, there's really only 10 channels you can use. In other countries, I think it goes up to 13, but in the US, there's only 10. There's one advantage of the 2.4 is there's a couple of channels outside of the Part 15 Wi-Fi range. And those are available for hams to use, but not for the general public to use. So you'll see those denoted in the interface as channel -1 and channel -2, and you can use those. So that's something to consider if you are having trouble finding available signal space. And then the 900 megahertz, there's only really 4 channels available in the 900 megahertz. The other thing to consider is the bandwidth of the connection. AREDN supports 5 megahertz, 10 megahertz, and 20 megahertz bandwidth. Some hardware does not support the 5 megahertz. I believe the MikroTiks do. I believe the Ubiquities do not. So that is something to consider. How that works out is, if you look at this diagram down here, you can see like a 5 megahertz bandwidth is only really using up the space of one channel. So you could put these on adjacent channels and be fine. With the 10 megahertz, there is a little bit of overlap, and with the 20 megahertz, there's actually a lot of overlap. And so you need to be careful as you lay out your network that you don't overlap channels and have them interfere with each other. We'll talk about that more in a sec. These protocols do support multiple users on the same channel. They use some different protocols internally. There's an RTS-CTS protocol. Anybody who's ever worked with serial ports remembers the fabulous RTS and CTS lines. RTS stands for request to send, and CTS stands for clear to send. And so what these radios will do is they'll actually send a very small packet saying, hey, I want to send something. And if they don't hear anything back, they'll wait and then try again in a minute, right? Or a few microseconds. I don't know how long it is. If the channel is relatively clear, the node that they're trying to talk to will send back a clear to send or CTS packet, and then they will send their actual traffic. The objective is to not have 2 people transmitting at the same time. What happens on 2 meters if you double with somebody? It doesn't sound great, does it? Imagine if you had 10 repeaters all sitting out there talking at the same time on the same frequency. They really have to work to get that communication handshake organized. That's something that has to be considered as we plan our network and lay it out. Other channels will overlap with others depending on the bandwidth, right? So here you can see these guys are all on the same channel, so they have to all work together to use that channel bandwidth effectively between them. It's much better if you can spread those out, right? This shows also how channels can overlap. And again, you have to be careful that you're not choosing channels that are overlapping, not just with other AREDN traffic, but with any other traffic that's out there. The nodes have a built-in site survey mechanism that is very useful to determine that. We can look at that in a minute. Yes.
So on the foot channel contention, each node is kind of independent. Is there a hierarchy of who takes precedence.
There is no
in order.
hierarchy.
They're all equally.
They're all
waiting
equally- Yeah.
For the time.
So
slot.
if I want to, if I'm sitting here on node A and I want to send data, I will send my RTS. And if I hear a CTS from somebody else, first thing I'm going to do is I'm going to listen. So it uses, what is it? CSMA
So carrier.
CA. Yeah.
Collision avoidance.
Collision avoidance. Yeah. So it's a CA.
Ethernet is
Yeah.
collision detection.
Yeah. So it listens first, and then if it doesn't hear anything, it'll send this RTS packet. And if it gets back a CTS packet, then it will go ahead and send its traffic. If other nodes are out there and they hear a CTS packet go out for not them, they will wait so that they don't obstruct that traffic because that's going to be coming, right? So the nodes will cooperate, they'll work with each other up to a point, and that point is when your network channel is saturated. That's when things don't work real well anymore. You can tell there's places to look on the interface where you can see how it's doing on that, and we'll go through that when we bring up the interface. Another thing to consider is this concept of hidden and exposed nodes, right? So if these nodes are all on the same channel, but A is farther away from C and can't really see him, he wants to talk, he's got to talk through B to do that. So if C hears B send out a CTS for A, C will know not to talk for a little while because A is going to be using the channel and B can only handle one at a time, right? So you want to plan your layout so that your nodes that are within view of each other are on different channels unless you want them talking to each other, okay? And that's something to consider too, is sometimes you have nodes that you don't want to talk to each other. Sometimes you have nodes that you do want to talk to each other. They have to be on the same channel to talk to each other. Okay, so this is a sample channel plan for an area. And you can see here we've got a single site over here that has 3 sector antennas. So one is on channel 178, one is on 176, and one is on 172. And they're pointed in different directions, right? The objective being that even though these are overlapping a little bit physically, their frequencies don't overlap. So they'll be able to operate independently, okay? Meanwhile, you've got 3 nodes running out of here on 174, 178. This guy, you've got the 178 over here, so it's not close enough to compete with this guy, and it won't bother these other guys that are on different frequencies, right? Same thing over here. You've got a node here, you've got a sector antenna here on 174 because it's far enough away from this 174 and this 174 that they don't interfere. This is an omnidirectional 172 channel over here. You want him farther away from the 172s that you've got out there, right? So this is what we need to consider as we plan out our network here in the Salt Lake Valley. How do we plan out where things are and who talks to who and make sure that our networks don't overlap, right? So in this example, you likely have a separate link radio that is on a different channel that both these guys are on and probably, this guy. So these guys are probably talking to each other, these 3, on a separate frequency, not one of these channels that they're using for the local. And that would be their backbone links, right? And this guy is probably, maybe he can't reach this guy, but this guy probably can because this guy's got some terrain in between him. So he's probably got a backbone link to him. He probably has one out there. There's probably one across here, right? So as you plan out your topology and what radios you're going to put where, you want to plan out that backbone as well as the local services. Okay. This is an example of a site that would be similar to one of those, like probably this guy right here where there's 3. So you would see a setup like this where you would have probably 3 sector antennas that are covering those 3 regions. And then you would have point-to-point antennas that are pointing at neighboring central nodes, right? And then anybody that's living in this area just has to point their single antenna at this guy and they're on the mesh, right? Or if they're in this area, they point here. Or if they're in this area, they're going to probably point it this way to get on the network. But since you've got those backbone links that are supported, you've got the ability to communicate across this entire area, even though you're on different frequencies, different channels, right? Does that make sense to everybody? Okay.
Gotta have more than 4 colors.
Well, actually, there's a proof somewhere about mapping that you never have to have more than 4 colors. So, okay. So the other thing that you want to think about, there are some things to think about when you're doing channel planning. If there are 2 towers within range of each other, they should be on different channels unless you want them to talk to each other, right? So ideally, you're going to put a point-to-point link on the same channel on those 2 towers that are looking just at each other. You might run that at a higher bandwidth. And then you'd have sector antennas on those towers that cover the surrounding areas that may be at a lower bandwidth because there might be more stations in there that you want to be able to fold that traffic into your higher bandwidth link. You should definitely use sector antennas for local coverage. Use directional antennas for point-to-point and backbone links. Directional could be a dish, it could be a Yagi, it could be, something that's not going to be a wide band setup. Sector antennas are typically going to cover either 90 degrees or 120 degrees. So that is something to consider as you're looking at equipment to put at various sites. What equipment do I want to put there? What's it going to be able to see? Where do I want to put that? That kind of thing. Dan.
So thinking about the trailer, we have one of those 5-inch, that's more of a sector end.
That would be the relay link, right? So you would have that connecting up to the backbone node somewhere. And then you would have a probably omnidirectional antenna on a second node that is providing local mesh access for anything mesh related around that area.
Okay, so the way we have it set up now, then we have access to the backbone. That's the purpose of that.
Right.
So that it participates in
Right.
the backbone when it's up and running.
Yep.
And then we need another antenna, an omnidirectional, for just.
If you want to support other local mesh nodes around the trailer. If you only want to, you do need another antenna if you want to support, we should talk about this offline. But the idea, what I'm thinking is you do want another node. It doesn't have to be an AREDN node. It can just be providing regular Wi-Fi locally, right?
But doesn't that do that already?
No, not necessarily.
Okay.
Like your SXT has only got one radio in it, and that radio is going to be the mesh radio. And that's the one that is your relay link back to the backbone. Okay. You would need another access point that we'll talk about it after. You want to keep in mind all of the links in the system. You want to not just think about, okay, this is my local little environment. I only care about what's happening right here. You have to think about the global picture, what's going on in the entire area. And in general, I mean, I think like LA is a single network. It's probably too big in that regard. It should probably be broken up into sub networks that are connected through a supernode. I don't think they've done that, but that area is pretty sizable. Here, I think if we did it county-wide, Salt Lake County, for example, would be one mesh island that would be the same level network. Maybe Davis County would be another one, Utah County would be another one, and we would have some kind of point-to-point links in between those. That doesn't mean we only have a single center point in Salt Lake County. We still want to have multiple networks, multiple frequencies in use, depending on the area within the county. And then we want our own internal backbone. But we would do a supernode link out to the other neighboring counties. We wouldn't have them on our mesh. Sam?
I've been talking to Orr Beach a lot
Yeah.
about this year. and give his recommendations for.
Work's a great guy, yeah.
And set up and everything, and look at, like, if we could put something up on Ensign Peak, we'd have 3 sector antennas, one for Twillett, one for Davis, one for Salt Lake counties. And we could cover all that.
On Ensign,
Yeah.
you want to hit
On
Farnsworth.
Farnsworth.
on Farnsworth, yeah, you could do that.
Look like that. Now, they could accomplish the buying thing, a secondary. I haven't done the RF plot, the sector for Ensign Peak yet. But it would be a good place to, like I said, so you'd have the sector antenna covering all the Salt, about all the Salt Lake Valley. And then a point to point to the Ensign Peak, which could cover
Salt Lake,
Canberra.
downtown avenues, that type of area.
Yeah.
Maybe one down at Point of the Mountain that hit Sandy Draper mostly.
Can't do the-
Okay, not downtown, but avenues, University of Utah area, that kind of stuff. Yeah.
Not case of nations.
Yeah, well, we've
Doesn't
had
matter
some
if we
experience
have
with
the
it.
houses.
They're gonna slide off anyway, right? So, yeah, so.
And so the way we place, for example, we had a node up on Ensign Peak. You know.
Or Farnsworth.
Node, I point my beam antenna to the sector antenna on top of Ensign Peak. And anybody else that could hit that could hit the Ensign Peak could get relayed to the supernode. And so that gets us, you know, to the rest of the world.
Yeah,
Yeah,
Farnsworth, I mean.
yeah, farm. I keep saying
I mean, Ensign has good coverage of the north end of the valley.
that. And then the other critical thing he was telling me is that they're finding that on 5.8, they can get up to 20 miles fairly reliably.
Yeah.
Beyond that, and that would cover all the way up in the East Bend.
Yeah.
From Farnsworth.
As bad as me with Babel and Babel.
And, but it won't reach, I think it's just a little more than 20 to get to the Ensign Peak.
Yeah.
In which, you know, back when they.
But if you had a point-to-point
they said
link,
40.
yeah,
You said
yeah.
35, 40 miles.
nice gain antennas, you'd have to make sure that they're aimed. And that would be a concern in an earthquake situation. Are they going to maintain that aim, right? And so, you know, we want to think about what's the result after an event happens, right? Because all of your stuff that's carefully aimed suddenly might not be carefully aimed anymore. But the workaround then is to have deployable relay nodes that we can take out and put somewhere that has a couple of antennas that we can point where we want them to go.
Anybody that could see both peaks from the back.
Yeah.
Just put up a second antenna.
Right,
Yeah.
exactly.
To route
And then they could be a relay. Wouldn't normally be used because that higher bandwidth connection would be chosen by default. But if that link went down, the mesh would automatically route around that. So something to consider. Okay, so there are a lot of software packages to do network modeling. I've used a couple of these. I've used the Ubiquity one, and I've used the VE2 DBE package. I haven't used the Hey, what's that path profiler or the Radio Fresnel tool, but those I understand are also really decent tools for doing this kind of stuff. The key things are that a lot of these packages will take into account distance, terrain, topology, altitude of the antenna. Like you can tell it this antenna is going to be at 150 feet or whatever. They'll take those things into account, but they won't take into account foliage. If you've got like a lot of trees around your property, like my house, I can't see a darn thing, right? So
All of it.
microwave, they say a microwave can go 50 miles or through one tree, right? So if you've got a tree on both ends of your link, probably not going to get through very well. If you've got only one tree in the way, you might get it through. It's a little dodgy, right? So those are things that we need to consider, and those are things that we know about from feet on the ground that the software obviously doesn't have any concept of. It doesn't know where the trees are. It doesn't know if they're pine trees or deciduous trees or whatever, right? So So that's something to consider. But there are a few packages out there that will do this kind of thing, and they are very useful for doing that. Okay, so the last slide, I said we would plan this out today. I don't think we've got enough people here to actually plan this out. So what we'll do instead is we'll take some time and we'll look at some stuff that I've done previously, and we'll poke around on my node a little bit and see what we can see. But this is Salt Lake County as it stands. And as you can see, it's pretty wide, it's pretty long. But we do have mountains on the sides that are handy. We do have Murray has a beautiful tower right in the middle of it. We also have IMC right there that's 14 stories high that we could put some sector antennas on top of that and probably get some really good coverage out of it. You wouldn't want to put them all co-located in the center because that limits your visibility down. So you'd want to put them at the edges of the building. I know Paul has been working hard with IHC to get buy-in on building some kind of network. I know Salt Lake City has been planning and specking out an AREDN network within their area that the city is on board with. I would love to do something similar here in Murray, and if any of these test beds that we build out are really proofs of concept for what we can do with this technology. And so as we get this working, we can point to our setup and say, look what we have. This would be much better if Salt Lake County Emergency Services actually supported some towers for us in a couple of different places, or, if the cities would do that. But that's the end of the slideshow. And then I will bust out of here if I can, if it will let me. Okay. And then I want to show you, there's a couple of things I want to show you. So this, let me bring up my documents first. So I've actually been working on a plan for AREDN here in Salt Lake, or in Murray. Where is that? Murray Amateur Data Network. Okay, let me make this a bit bigger so you guys can see it. Maybe I can. Okay, so these are some kind of ideas for a network layout here in Murray. And these were made before I dug into how all of this works and how, where you want your backbone links and that kind of stuff. And so my thought process was the main hub is going to be on the tower. Our tower is what, 200 feet high, right? If we put something at, say, the 100-foot level, it would have pretty good coverage over most of Murray. And in fact, this is a diagram. This was generated by that Ubiquity tool. And what I put on here was 3 sector antennas on the tower and then a omnidirectional antenna at each of the fire stations, just on the roof. Nothing fancy, just a very simple antenna on the roof of the building. So nothing like 50 feet in the air or anything like that. These are just right at ground level or building roof level. Yes.
Are you taking into consideration existing registered mesh node?
No, I'm not. Not in this case. I'm strictly talking about a plan. This is a proposal that I've been putting together for ARDC to try to fund a data network here in Murray.
The only map that I know. It's on Salt Lake Peaks Amateur Radio Club website,
Yeah,
and it gives pretty much the whole valley.
really?
Yeah,
Can you send me a link to that?
Which website?
So it makes, it's, no, great.
yeah. It's interactive, you can see it from the top. But those are actually registered nodes.
Okay, this is old.
Oh, yeah,
Yeah, this is way old, right? So,
but some people do actually update
yeah,
it.
well,
Most of it is still existing. I'll see everyone later.
see you, Dave. Thanks for coming.
Be safe.
So this is the coverage that I could expect to see from from three sector antennas on the Murray Tower and an Omni antenna at each fire station.
And did you do the 100 foot at the Marine Tower?
I don't remember which altitude I used. I think I said 50 meters. Yeah, 50 meters, so 150 feet-ish.
Okay.
Is this the animal control?
Yes, this is the tower at the animal control where Mark's repeater is located. And so it would cover really good coverage, pretty much out into Cottonwood, half of Taylorsville, decent coverage all the way through Taylorsville, West Jordan, Midvale, Holiday, and South Salt Lake. And then kind of dodgy coverage out further, right? But those cities aren't in Murray, so I didn't really care too much about them. No. But this,
That would actually get out to Cotton Heights.
it would hit Cottonwood Heights, yeah. So Cottonwood Heights
Did you get City Hall?
is out in here. I don't know. I'm not sure where the city hall is there. We would have to do a site survey with that, right? And figure out where we would actually put them. But my concept was putting a node at each fire station was kind of the direction that I was initially going. And then potentially, so this is showing nodes at each fire station, right? And at each elementary school. This was back when we had the Safe Neighborhood Program, and the elementary schools were going to be the mustering locations. Some cities are still doing that. Some cities have chosen to go a different way, but the county is no longer sponsoring that. But the concept was to put a node at each elementary school, and these could be solar powered with a battery, just sits on the roof of the school, right? Yeah, it doesn't have to be that big. I mean, these things don't draw a lot of power. Well, I don't know. We'd have to figure that out. We'd have to figure that out, obviously. But yeah, this is kind of a plan out with a node at each elementary school. And this is like a potential routing of how schools could see each other, because some of the schools like Parkside is down in the gully there in the park, right? And so it's not very visible from like Station 82, but it would be visible it would be able to see the tower just fine, and it would probably be able to see McMillan without too much trouble from down in there. So you can get kind of an idea of how these links would appear to the mesh. Um, Obviously, I have not actually deployed anything, so I don't know which of these links would actually come up and be preferred. And I wasn't thinking anything about using different frequencies or anything else. I was thinking we'll put everything in Murray on the same frequency and it'll be fine. Maybe it won't be fine. I don't know. That's something that we'll have to experiment with. But these are some of the things that I was planning out as I was researching for this. I've been working on this proposal for a couple of years. So um, some things have changed as far as the software goes. There's different hardware available now that wasn't available then that may make things easier, may make things harder. I don't know. All these things will have to be reevaluated. This was at the time existing nodes in Utah, right? Similar to your map here, you can obviously see there's not nearly as much.
Somebody have more up to date.
Yeah, there is some up-to-date information, but it's only nodes that are on the Superlink, the supernode, right?
Our website's New World now
Yeah.
it's currently updated 4 times a day, but they only update it based on what's connected to its supernode.
So this is my travel node, which is this little guy right here. And you can see it's actually fully participating in the local mesh right now. It can see 19 nodes. and 25 devices. It has a single tunnel out to my HAP sitting at my house, right? And that HAP also has a tunnel into Sam's node. And from there can access the supernode. So if you look at this one right here, this shows you everything that's on the local mesh right now here in the Salt Lake area. Let me make that a little bit bigger so you can see it. Now, when it says excellent, good, fair, and slow, just because it says slow doesn't mean it's actually slow. It's just based on the number of hops. And you can see each of these has a little number that says how many hops away it is. So like my travel node is 0 hops from itself. So obviously that's excellent, right? I can reach that very well. My home node is 1 hop away via the tunnel. It is DTD connected to this guy, which is 1.1 hops away. DTD nodes are considered to be 1/10 of a hop as far as the software is concerned. Then I've got LB1 is my light beam, and I'll show you that in a second. But I have that sitting in my basement, but my phone is attached to that one. My VoIP phone is attached to that one. If you look at this guy, he's also got my ham clock on there. So if I click on that, I should be able to pull up my ham clock, theoretically, if it's going to work. Come on, baby.
It's a live demo, so no, it's not.
It's a live demo, so it probably won't work, right? There it is. Look at that. See, so there's my ham clock sitting in my bedroom at home on a Wi-Fi LAN connection to my HAP. And I'm hitting that over the tunnel, right? So that's kind of cool. You can see here's the supernode. It's 2.1 hops away. Yeah. Is it? So I'm tunneling into this HAP here, and then he's got a DTD connection to the supernode, right? And so all of these guys are here. These are all on this network that is homed out of Sam's machine at his house. And you can see some people have different stuff on here. We've got Mesh Chat is running. We've got a couple of phones out there.
Dude, go over there and get on that solar controller there. RV there. And see if it'll bring up. Shows her that.
So I can see the battery in Sam's RV, how well charged it is. So that's kind of cool. If you had a node that was mounted on a building or something, you could tie that node, that solar controller, into the network, and then you could review the telemetry that way. And you'd know if the batteries needed to be replaced, or you'd know if, it wasn't getting enough sun or whatever.
Wouldn't it be nice to have a solar control?
It sure would. It would be nice to have something there.
Anything with a built-in HDMI access, you can just connect.
Yeah.
To a hat light
and share that as a device, right? So let's go look out at this one. Gives me the super node, the super mesh. So if I click on this guy, it's actually pulling this from Sam's super node. And so you can see all of the stuff that's out there. This is not local, obviously. We've got some VE stuff. This is in Canada. We've got G7. I think that's in the UK. We've got N3 FUD, whoever he is. I can get to any of this. So just as an example, let me show you this. And if I have it up, do I have it up? Let's see.
It's interesting if you have a device, you can get on and start browsing around with everybody else. It's amazing what people are.
This is my WinLink client here. And you can see I have it set as Telnet Post Office for my connection method. And if I open a session, I'm actually hitting W6BI on the mesh. And I can run a connection out to him and do a WinLink connection over the mesh. Isn't that cool?
Are you providing the service? Or is
No,
he providing-
he's providing the service. I'm accessing it as a client.
You can come as a client on his.
He's got an RMS that's on the mesh, and that RMS has a connection to the CMS so he can get WinLink messages. He's also running a local post office, so if his internet connection went away, you could still access that RMS over the mesh. Yeah.
Have any of you participated in the Wasatch 100 every year? For about 4 years, we ran a mesh network from Scott's to the finish line. And we picked up Brighton. Well, Brighton was a problem because it was a hidden node down in the hole. But you know how slow it is to run the packet.
Yeah.
When you run
Run it on the mesh?
Element section
Yeah.
on top of mesh, you'd be amazed at the performance of that network.
Yeah.
Of
So
that entire database system.
if I'm looking out here, here's a Las Vegas supernode. This guy's got an NTP server out there on the mesh. So I could point my nodes at him for time, and they would do NTP time synchronization through him over the mesh.
It has a Minecraft server.
Yeah. I wouldn't be surprised. This guy's got a camera. I can click on this,
So we
and this is live video. It comes up,
Stuff.
live video from this guy's QTH over the mesh. We could put cameras on these things. We could put phones on them. We could put whatever you want to put on there. Anything you can run over the internet, you can run over the mesh. Now, obviously, we're depending on the internet to run these tunnels, but on our local mesh, we could run all of these services ourselves and not have any internet connectivity at all and still be able to access all of these services
We
running just on
need
our
one of
app.
Those, one location to do Starlink.
And if you have one location that's providing a Starlink connection,
Yeah.
that's a connection into the internet.
I don't know, made the supernode, like we have a Starlink. No.
Sam's got a Starlink, so yeah, I mean,
No, I'm having a hard time getting,
I've also got one as a redundancy.
you got a Starlink as well, Chris?
Yeah, it's not live all the time. I'd deploy it in the event of a loss.
but we're looking at the, like I said, not having a good luck getting, existing repeater operators to respond to me. But when we do start communicating with these guys,
Show them some of this stuff.
I can show them, look, we'll put a camera right there, you'll be able to monitor equipment, you'll be able to watch the weather as it rolls in. You know, we can throw cameras up there and you can watch the stuff live.
See, that's for the Murray network that I've been proposing. I want to put a remote controllable camera on the tower that from the mesh connection, you can point it in any direction. Obviously, the resolution is not going to be great. You're not going to be like peeking in somebody's window with it, but you'll be able to like get an overview of the valley and see, oh, that bridge is damaged. I can see that visibly. I know not to route anybody through that area because they're not going to be able to get under the freeway there
And
or
if you-
whatever.
If you have the camera up there and you're watching it after the earthquake and you just see weeds.
Yeah, you'll know the power's down, right? Yeah. So, yeah.
That's another impressive thing I've been seeing from the guys in California, they're showing that they're spotting wildfires.
Yeah, with their cameras. Yeah,
And-
before anybody ever sees them. Yeah.
And we're finding authorities.
Yeah.
The wildfires from down here. And
So, I mean,
I do have some.
yeah,
so it's pretty,
That's supposed to be,
Well,
well, it's on the recording now. Uh, Um, Yeah, so
Thing up there is stuff in shot. And dish is a target. And there's a building up there that's got some amateur equipment that's just brutal. Mill shack? I don't know what's in there. I wouldn't stand in there. I got pictures of the inside. You see a 10-7 CSW on that, that's like,
I do not see CSW.
Hmm?
I do not see a CSW.
That's the L3 node, that's all, should be K7 CSW.
Yeah. Oh, that was the other thing we were gonna look at. So this link brings up the map of what is known. And these are nodes that are on the local super mesh, right? So the ones that are accessible from Sam's node. So you can see here's Sam's node here, and then there's a link out to this guy, W7PKA. I know he's been trying to get a link to me, an RF link, but I don't have an antenna pointed at him right now.
The only RF.
Yeah,
Wasatch Front.
actually, I have one between me and Chris right here. You can see it right here.
The only RF.
That's the RF link, right? So that's from my LDF5, which is currently stuck on top of my kid's swing set. My youngest kid's 26, so I don't think he's swinging anytime soon. But it's stuck on top of his swing set and pointed in the general direction of Chris's house. And Chris has a LDF, LHG that's pointed south, and I'm able to hit that. So this is the RF link.
Who is that right there?
This one is me.
I know that.
This one is Chris
Chris.
Hardy.
He's the,
Okay,
just spoke on the, already. You got Chris?
we got another Sanford, huh?
Yeah, well, he's on he's not
I'm
on
here. I'm on Capri.
he's on Capri, so
Oh, you're on free.
Yeah.
Okay.
just a couple streets over. But
I can get W7PKA from Sugar House, the mesh test. At 900.
clear over there.
Yeah.
I've also got a second dish on my roof that's not hitting anybody that's facing west right now if I need to swing that around.
Swing it kind of southwest, maybe. See if you can hit PKA, or you could try to hit one of the guys over on the east side. But yeah, so right now we're totally dependent on these tunnels. I want to fill this in with RF links and have an actual network going here. And that way, if the internet goes down, we don't go down. We're still able to do stuff. But just looking at the capabilities, it's like, you look at what it can do and you think about that and think about how can people not be excited about this, right? But yeah, that's what I wanted to show you guys, what I wanted to talk about. And we do need to like start planning where we're going to put things, where we want to put things. We need to start planning what equipment we need to acquire. We need to put in some of these ARDC grant requests because they will happily fund this kind of a setup. And if we have it covering the entire Salt Lake Valley, they would love that more than funding just Murray City. So
Get around the city line to buy. For the hospital.
yeah,
It runs to the.
see, that's a tough one because it has to be operated by an amateur, right? So it has to have an amateur call sign attached to it. Now it could be a club call sign, I suppose. We could leverage it that way. And if they want to purchase the equipment and donate it to a separate club that we form just to do mesh networking in Salt Lake County, we could probably make that work. But I don't know. No. No, as long as we can remotely control it, that's all that matters, right? These are they're just like repeaters, essentially. So you don't have somebody sitting on top of Farnsworth with their finger on the button on the 6.2 all the time. Although it would be nice sometimes if you did, because I've heard a lot of crap on the 6.2 lately. But As long as you can get to it, shut it down, that satisfies the requirements.
So if my steam plate picks up the VoIP phone, dials a number,
That's a gray area, right? Because the data is moving between the nodes all the time anyway. Does it count as third-party traffic? I don't know. That's the gray area. And I know there's a lot of places that are saying, a lot of people are saying, yes, you can't do that without having a ham standing next to the phone. And yet there are other people who say, oh, yes, that's no problem at all, right? So I don't know. It would be nice if the FCC would come out with a ruling, but as far as I know, nobody's tried to get them to because they're afraid they're going to come out with one that isn't good for us. But
now
it might be something that needs to happen. Yeah. So we'd have to chase that through other means. I don't think anybody here is a registered lobbyist, but we could run that through ARRL maybe and see if they could propose something.
The way it stands now, and the way, at least with Paul's been talking with AHC, is their understanding that it's an emergency use only.
Yeah.
And in that situation, yeah, anybody can pick up
True.
the phone and dial it.
It has to be a real bona fide emergency though, not a test, not a, if they want to do a test, they need to have a ham standing by, but that ham doesn't necessarily have to be sitting on the phone. He just has to be in control of the equipment, right? So
if you're gonna have somebody videotape, it's not me.
well, I don't know. That's a gray area. There have been discussions on the AREDN lists about, you know, the hams are responsible for the infrastructure, not for the data that's traversing it. But at the same time, there are efforts to not use encryption on any protocols that are running on the mesh because we're not allowed to use encryption. And finding protocols that don't use encryption to do things can sometimes be harder than not. So those are areas that have to be addressed, and we need to make the effort to address them. Still doesn't stop us from building out a fun network to play with, which is a great test bed for this kind of stuff. Okay, I'm gonna close down the Zoom. Maybe if I can figure out how to do that from here. Where is my Zoom control panel?
Thanks, John. That was good.
Everyone have a good night.
There it is. Stop share, and I will stop the recording. If I can find the button to stop the recording. There it is. Okay.